Hello friends, this is third video in the series of structural analysis fundamentals. I am Dr. N.S. Naik from the Department of Structural Engineering, Sanjeevani College of Engineering, Kopargaon. Friends, in this video we will discuss 10 questions based on fundamentals of structural analysis. So let us begin with question number 1. In this question, one figure is given and you have to comment about the stability of the structure. So you have to comment about the stability of the structure. So this is the structure under consideration and you have to comment about its stability. The answer is the given structure is unstable. So first of all, the structure is unstable. For stability, let us see what is the requirement. For stability, the three reactive forces should be non-parallel. The forces should be non-parallel and they must be non-concurrent. They must be non-concurrent. So here the forces are concurrent. Here the forces, reactive forces are concurrent. They are meeting at this point, though they are non-parallel. Okay. And the support system, this is important point. The support system must be adequate to avoid the rigid body motion of the structure. Now you can imagine if a load is applied on the structure will move because at A, B and C roller supports are there. So the support system must be adequate so as to avoid the rigid body motion of the structure, and that's why the given structure is unstable. That's why the given structure is unstable. This is the answer for question number 1. Question number 2. What is mean by structural linearity? It means that structural linearity means that the magnitude of the displacements and internal forces of the structure are directly proportional to the magnitude of the external loading, and the internal forces and the displacements disappear completely when the applied load is removed. Here we will consider a very simple example. Let us consider a rod on which force F is applied. On which force F is applied. Let us assume that the rod is fixed at this end. Okay. Now if because of this load delta L is the deformation of the rod and there will be some force, internal force developed in the rod. Okay. Now if you remove this force F, the deformation, that is delta L, and the internal force both will disappear. This is called as structural linearity. So again I am reading the answer. It means that the magnitude of the displacements and internal forces of the structure are directly proportional to the magnitude of the external loading. As the load increases, deformation will increase. The internal forces and displacements disappear completely when the applied load is removed. So this is called as structural linearity. Question number 3. State the Clerk-Maxwell's reciprocal theorem. Clerk-Maxwell's reciprocal theorem. Its name indicates reciprocal theorem. So let us discuss its statement. This theorem states that for a linear elastic system, the system must be linearly elastic. The displacement at any point I due to unit load applied at J is equal to the displacement at point J because of the unit load applied at I. This is the statement of Clerk-Maxwell's reciprocal theorem. Now in this first figure, there are 2 points on the beam are considered I and J. Load is applied, unit load is applied at J, and this is the deformation of the beam, or say the deflected shape of the beam. Now point I will move to new position. This is new position of I, and this is yi, means deflection of point I. Now this deflection is result of the unit load applied at J. Okay. So sometimes we can write is like this: y I j means deflection of I because of unit load at j is equal to is equal to. Now the second case. Now in this case, the load is applied at point I and this is point J. Load is applied at point I. Unit load is applied at point I. And this is the deflected shape of the beam. And this is Yj. This is Yj. Now according to this reciprocal theorem, deflection at I because of unit load at J is equal to deflection at J because of unit load at I. Means here we can write deflection at J because of unit load at I. So this is called as reciprocal theorem. This is called as reciprocal theorem, or more precisely Clerk-Maxwell's reciprocal theorem. Now let us move to the next question. For a fixed beam shown in figure, the fixed end moments are as shown. So this figure shows a beam carrying 2-point loads W1 and W2. And these are the fixed end moments developed at fixed supports A and B. So MAB is the fixed end moment at A, MBA is the fixed end moment at B. The fixed end moments at A is anti-clockwise and that at B is clockwise. So how you will justify the direction of moments? Why the fixed end moment at A is in anti-clockwise direction and why the fixed end moment at B is in clockwise direction? That you have to justify. A reason is very simple. If we consider a simply supported beam of same span as that of the above fixed beam carrying same type of loading, that is W1 and W2, W1 and W2. Now what will happen? Because of this downward loading, the beam will deflect with convexity downward like this, and this is theta B, which is in anti-clockwise direction. This is theta B, which is in anti-clockwise direction, and here this is theta A, which is in clockwise direction. This is theta A. Okay, this is theta A. Okay. Now in case of fixed beam, the fixed support, it offers resistance to this rotation and it avoids the rotation at A. Now to avoid a clockwise rotation at A, fixed support offers anti-clockwise moment. Similarly, to avoid anti-clockwise rotation at B, fixed support B offers clockwise fixed end moment. This is the justification for the directions of MAB and MBA. You can read this paragraph for better understanding. Let us move to question number 5. A continuous beam. Here you should read it as continuous. A continuous beam is statically indeterminate externally but determinate internally. Two statements are given. Statement A is continuous beam is statically determinate externally, statically indeterminate externally and determinate internally. Statement B is for continuous beam, one can plot SFD and BMD after knowing the support reactions. So you have to select the correct statement or statements. Which statement is correct? Four options are given. Statement A is correct, B is wrong. Both A and B are correct. Statement B is correct, A is wrong, and both are incorrect. So here both the answers are correct. Both the answers are correct. Here the correct answer is no. This is by mistake. I have written it. Don't read it. Continuous beam is statically indeterminate externally. See, continuous beam, it carries number of supports like this: 1, 2 and say 3. Okay. Suppose fixed at this end. Okay. So number of reactions are there. So we cannot calculate these support reactions using conditions of equilibrium alone. So continuous beam is statically indeterminate externally. Statically indeterminate externally. So this is the first statement which is correct. Okay. But determinate internally. Once you know the reaction, suppose 2, 5, 8, suppose this is 0, here this is say 10, and the resisting moment or moment at the support is say 5 kilonewton meter. If you know these reactions and the loading is given, after knowing these reactions, one can easily plot SFD and BMD. And hence, after knowing the reactions, we can calculate the internal unknowns. Means it is internally determinate, while externally indeterminate, statically indeterminate, externally. Means we cannot calculate the reactions using conditions of equilibrium. But internally it is determinate because we can plot SFD and BMD. So this is the first statement. It seems correct. It is correct rather. Statement B, let us check. For continuous beam, one can plot SFD and BMD after knowing the support reactions. So this statement is also correct. And hence, both A and B are correct. Both A and B are correct. This is the answer for this question. So here it must be 2. Here the correct answer is 2. Here the correct answer is 2. That is both A and B are correct. Okay. So in this way you can justify your answer. It is externally indeterminate but internally determinate. And once the reactions are known, we can plot shear force diagram and bending moment diagram. Right? Next, lack of fit causes additional stresses in indeterminate trusses, while the determinate trusses can accommodate it. Whether it is true or false, the correct option is true. Let us consider a determinate truss. This truss is determinate externally. There are two reactions at A and only one reaction at B. See. So we can calculate the reactions using conditions of equilibrium alone. Now it is internally determinate. For internal indeterminacy, internal determinacy, only one member is required. So that member we can add a diagonal member. Now if this member is short, during fabrication it happens, this member is short in length. So forcefully the fabricator fixes it forcefully. But since the structure is determinate, it can accommodate this forcefully fixing of this member, because this structure, it provides freedom. So it can be accommodated without developing additional stresses. But in case of indeterminate structure like this in the second figure, here this is indeterminate structure, means it is having one more member, diagonal member, then it will become indeterminate. If these are the members 1, 2, 3, 4, 5, then the structure is determinate. We know the formula, degree of internal indeterminacy m minus 2j minus 3. But here there are 1, 2, 3, 4, 5 and one more member is there, 6. Now if the sixth member is short and if we are forcing that member to fit in position, and since it is indeterminate structure, this forcefully fixing of this member in position will create additional stresses in all the members, and hence the given statement is true. The given statement is true. Question number 7. Complete the statement. For a two-hinged parabolic arch carrying uniformly distributed load over the entire span, the horizontal thrust is equal to, and the correct answer is 25 WL upon 128 H. where W is the intensity of loading, L is the span of the arch, and H is the height or crest height. Okay, H is the crest height. For a 2-inch parabolic arch carrying UDL over entire span, parabolic arch carrying UDL over entire span, this is A, this is B, this is load intensity W, this is crest height H, and the reactions. The reactions are VA, VP, HA, and HB. So for equilibrium, HA is equal to HB is equal to H, and this value is equal to 25 W into L upon 128 H. This is standard formula which we can derive using different methods. Question number 8. For a frame shown in figure, identify the diagonal members which are in tension. Now in this figure, because of this horizontal load, this frame will try to sway like this. And here member BD is subjected to compression. It is evident from the figure, while the second diagonal member AC is subjected to tension. So AC is in tension, BD is in compression. Simply you have to imagine it. Ninth, for a beam shown in figure, if moment applied at A is equal to M, what will be the magnitude of moment developed at B, far end B? Also mention the sense of that moment, that is clockwise or anti-clockwise. So this is a simple case of carryover moment. We know when a moment M is applied at the simply supported end for a beam, then at the far end the moment developed will be equal to M by 2. This is called as carryover moment. In moment distribution, this is called as carryover moment, and it will have the same sense as that of the applied moment, again to avoid slope at B, because due to this anti-clockwise moment, the possible rotation of B will be in clockwise direction. Possible rotation I am talking about. And to suppress this rotation, the resisting moment must be in anti-clockwise direction. And now, because of this anti-clockwise moment, now the beam will bend like this. I will show you how the beam will bend. It will bend like this, and at B slope will be equal to 0. So this is the correct answer for question number 9. Question number 10. Identify the zero force members in the truss. Now to identify zero force member in a truss, we are using two conditions. So first condition is if two members are meeting at a joint. If two members are meeting at a joint which are non-collinear. If two members are meeting at a joint non-collinear and that joint is not carrying any force, then force in each member is equal to 0. So according to this condition, member DE and CE both are meeting at joint E and there is no load acting at point E, and therefore force in member DE and force in member CE is equal to 0. At D, 3 members are acting. At C, 3 members are acting. So this, according to first condition, these two members are zero force members. The second condition to identify zero force members is if 3 members are meeting at a joint like this, of which 2 are collinear and third be at an angle. So 3 members are meeting at a joint and the joint is not carrying any load, then the force in the third member is equal to 0. But this second condition we cannot apply for this truss because the joints are carrying load. Okay. And according to first condition, again I will repeat it. If two members are meeting at a joint, non-collinear, joint is not carrying any load, then force in each member is equal to 0, and hence the correct answer is DE and CE. These are the zero force members. These members are not carrying any force. So these are the fundamental questions from structural analysis. This is our third video. So all of you please go through the video and revise these questions and answers. Thank you.